Hello students, welcome to today's physics lesson. Our topic is optical spectra. By the end of this lesson, you will be able to define a spectrum and spectroscopy, explain visible light and the electromagnetic spectrum, describe emission spectra, differentiate between line spectra, band spectra, and continuous spectra, understand why spectra are important in identifying elements. The study of spectra is called spectroscopy. A spectrum is the arrangement of electromagnetic radiation according to wavelength or frequency. Optical spectra include the spectra of visible light and other forms of electromagnetic radiation. Spectra may appear as emission spectra, produced when a substance emits light. Absorption spectra, produced when a substance absorbs certain wavelength of light. The type of spectrum observed depends on the nature of the material and its temperature relative to the light source. Can humans see the entire electromagnetic spectrum? No. The human eye can see only a very small part of the electromagnetic spectrum, called visible light. Visible light makes up only about 0.0035% of the entire electromagnetic spectrum. The electromagnetic spectrum include radio waves, microwaves, infrared rays, visible light, ultraviolet rays, X-ray, gamma rays. Only visible light can be detected directly by our eyes. Emission spectrum. An emission spectrum is the spectrum of electromagnetic radiation emitted by a substance. It appears as bright colored lines or bands because specific wavelengths of light are emitted. There are three main types of emission spectra: line spectra, band spectra, and continuous spectra. Line spectra. A line spectra consists of separate bright lines at specific wavelengths. According to Bohr's atomic model, electrons exist in fixed energy levels around the nucleus. Hydrogen gas or any other gas enclosed in a tube will not emit light unless energy is supplied to its atom. When a gas atom absorbs energy, it is said to be excited or energized. Excitation can occur by heating the gas or passing an electric discharge through the gas by applying a high voltage across a tube containing the gas at low pressure. The electrical energy supplied excites the gas atoms, causing them to emit light as they return to lower energy levels. This light appears as distinct spectral lines. Hydrogen gas emits several characteristic lines including red, blue-green, violet. For sodium vapor, it emits two bright yellow lines with wavelength 5.890 times 10 raised to the power minus 7 meters and 5.896 times 10 raised to the power minus 7 meters. For each element, only specific wavelengths are emitted, producing its own unique pattern. No two elements have exactly the same line spectrum. Because of this uniqueness, spectral lines are often called the atomic fingerprint of elements, similar to how each human has unique fingerprints. Scientists use line spectra to identify elements even when only tiny amounts are present. Band spectra. A band spectrum consists of groups of very closely spaced spectral lines. Because the lines are so close together, they appear as broad bands. Band spectra are usually produced by molecules, molecular gases, and chemical compounds. They are obtained when gases or vapors are heated or electrically excited. Example: nitrogen produces a band spectrum. Band spectra consist of many closely packed lines produced by molecules rather than individual atoms. More complex than line spectra, resulting from molecular rotation and vibrational energy changes. Therefore, band spectra are often called molecular spectra. Continuous spectrum. A continuous spectrum contains all wavelengths within a particular range without any gap in a continuous spectrum. Colors merge smoothly into one another. Continuous spectra are produced by hot solid, hot liquid, dense gases from sources like the sun, incandescent lamp, molten metal. A white-hot tungsten filament in an electric bulb produces a continuous spectrum. Why is it called continuous? Because every wavelength is present, there is no break or missing colors. A rainbow is a natural example of a continuous spectrum. It forms when sunlight enters raindrops and undergoes refraction, internal reflection, refraction again as it leaves the droplets. Different wavelengths bend by different amounts, separating white light into its component colors. Since the colors blend smoothly into one another without sharp boundaries, a rainbow is considered a continuous spectrum. The continuous spectrum produced by hot, dense objects is called a thermal spectrum. Any solid, liquid, or dense gas above absolute zero temperature emits electromagnetic radiation. Examples include the sun, stars, electric lamp filaments, hot metal objects. These objects emit radiation over a wide range of wavelengths. Let's quickly review what we have learned. Spectroscopy is the study of spectra. Humans can see only the visible light region of the electromagnetic spectrum. Emission spectra are produced when substances emit light. There are three types of emission spectra: line spectra, band spectra, continuous spectra. Line spectra are produced by atoms and are unique to each element. Band spectra are produced by molecules and appear as group of closely spaced lines. Continuous spectra contains all wavelengths and are produced by hot, dense objects. Rainbows and incandescent lamp filaments are examples of continuous spectra. Spectral lines are called atomic fingerprints because they help identify elements. Class exercise. Thank you for watching. Don't forget to revise your notes and attempt the class exercise. See you in the next lesson, Absorption Spectra.